This video is about symmetry, and in particular, even and odd functions. So, there's three kinds of symmetry that we typically talk about. There's symmetry about the x-axis. So here's the x-axis. Notice that the top looks like the bottom. If you cut this out and you swiveled it around the x-axis, you get exactly the same picture. So you could actually summarize this sort of with a point xy is on the graph if and only if the point x negative y is on the graph. So why wouldn't that be a candidate for being an even or odd function? Answer, it's not a function. It fails the vertical line test. So you might say something in your notes like not a function. Okay? Well, symmetry about the y-axis. Notice here, if a point xy is on the graph, then the point negative x, y must be on the graph. Well, that seems pretty natural. In fact, if this were your point x, y, can you see that negative x would then be a positive number? So it works both ways. This is what we call an even function. So if it's symmetric, if it's a graph of a function that's symmetric about the y-axis, we call it even. We'll talk a little bit later about why. The last thing we have is something that's symmetric about the origin. So symmetric about the origin right there. Imagine if I cut out around this and then spun the entire picture. Okay, if I spun the entire picture, we would get the same picture. That means this point, oops, and I was doing that in black. This point xy is on the curve if and only if the point negative x, negative y is on the curve. Okay? This is what we call an odd function. So if a function is symmetric, if a function's graph is symmetric about the origin, we call it an odd function. So I have three examples here. How do we look at these functions and say, is this possibly an even function? Is this possibly an odd function? There's a slight issue with the name because if I give you an integer, you're going to say, well, gee, it's either even or odd. If I give you a function, it's either even or odd or none of the above. Well, why? Because not every function is going to have the right side look like the left side or going to have the right side be able to twist and look like the left side. In fact, probably most of the functions you look at are neither even nor odd. But you ought to be able to recognize when they are even or odd. So let's take a peek at this. Okay, so we have this right here. I want to know if it's even or odd. I know what happens if you plug in x. The question is, what happens if you plug in negative x? If I plug in negative x and I get out the exact same output, it's even. If I plug in negative x and I get out the exact opposite output, I know it's odd. So we'll do that. F of negative x, plug in negative x everywhere. We'll follow the rules. What's the absolute value of negative x? You guessed it, absolute value of x. Negative x times negative x is x squared. Hey, look, the output for x is the same as the output for negative x. Therefore, this is even, okay? How about here? F of negative x, so that's negative x squared plus 2 times negative x minus 1. Negative x times negative x is x squared minus 2x minus 1. These aren't the same, and they aren't the negative of each other. So these are neither even nor odd. So you could say neither, or you could say not symmetric. Okay? Last but not least, f of negative x. So that's negative x minus 1 over, plus 1 over negative x. Okay? Oops. That's where my parentheses in. Now, I could factor this negative out here, And in fact, I could factor a negative out from both terms. So can you see this is really negative the quantity x plus 1 over x? In other words, this is exactly negative the output of this. So this is odd. And you can see the same thing as the graphs. So look at this, and here you see it. We have one even function and one odd function. This one's even. It's symmetric about the y-axis. This one is odd. It's symmetric about the origin here. And this one is neither. It's not symmetric about the y-axis, not the same picture if you reflect there, not the same picture if you rotate. Doesn't have to be either one.